All right, let's dive right into this explainer. Today we are taking on a really fun topic as we jump into Chapter 3 and embark on a truly fascinating journey. We're taking something you see every single day, the circle, and exploring it from the ground up. We'll go from simply spotting these shapes in our environment to mathematically mastering their properties, and finally to using them for some incredible artistic design.
Here is our quick roadmap for today. First up, circles in our world. Then, drawing perfect circles. Third is finding the center point, followed by inside, outside, or on. And finally, we'll wrap up with creating circular designs. Let's get moving.
Section 1. Circles in our world. Spotting shapes. You know, the circular shape is absolutely everywhere around us. I mean, think about it. From the face of a clock ticking on your wall, to an old CD, a painted tin, or even the shiny top of a snare drum. Our sources make a great point here. Before we can really study geometry, we first have to recognize it out in the wild. Seriously, how many circular items do you think you've walked past today without even noticing?
Section 2. Drawing perfect circles. Tracing round items.
So our sources suggest a super practical approach for this. Imagine grabbing a basic teacup, a saucer, or just a small coin. You place it flat on a piece of paper, grip your pencil, and literally just trace tightly around that edge. It's such a simple physical action, right? But it's actually the absolute foundation of geometry. By tracing different objects, you're physically taking a three-dimensional property and transferring it right onto a two-dimensional plane. The crucial takeaway here is this. That complete curved line you just drew, that is mathematically known as a circle. And notice I said the complete line itself. Now, depending on what you traced, maybe a tiny coin or maybe a massive drum, they can be wildly different sizes. But the mathematical definition, it stays exactly the same. It's a complete, perfectly closed, curved line.
Section 3. Finding the center point. The fold line method.
Okay, so we've drawn our circle, but now we hit a real puzzle. How exactly do we find its exact center? I mean, if you just drew a circle by tracing a cup, sure, you have that outer boundary mapped out perfectly. But how on earth do you mathematically pinpoint the absolute perfect middle of all that empty space? You can't just eyeball it if you want to be precise. We definitely need a reliable method.
Let's try a physical activity and see how this actually works. By cutting out the circle and folding it, it kind of reveals its own secrets. To solve our puzzle, we turn our drawn circle into what the sources call a circular lamina, which is basically just a fancy way of saying we cut it out from the paper. Then fold it perfectly in half into two equal parts and mark that crease line with your pencil. Open it back up and fold it in half again, but along a completely different axis. Finally, mark that second line. What happens next is just brilliant.
Look at the result of our little experiment. No matter how many times you fold that circular piece of paper exactly in half, every single one of those fold lines is going to cross at one exact location. That intersection? That is the absolute mathematical center. It's such a beautifully elegant way to physically prove a mathematical concept. Literally no complex formulas required.
And through that simple folding activity, we establish a golden rule of geometry, the center rule. It basically states that the distance from that center intersection point we just found out to any point on the curved edge is always exactly the same. You could take a ruler and measure from the center to the top, the bottom, left, right. It will never change. That uniform distance is the very defining characteristic of what makes a circle an actual circle. Section 4. Inside, outside, or on. Identifying positions.
So now that we know the anatomy of a circle, including its boundary and its true center, let's clearly define the space in and around it. Grab a mental pencil for a second. Picture drawing a circle. Now, mark a big X clearly inside the boundary. Next, put a solid dot right on the curved line itself. Finally, draw a check mark completely outside the boundary. You see, a circle effectively divides the universe into three distinct, separate zones: the interior, the exterior, and the boundary line itself.
To see why this spatial placement actually matters in a practical sense, think of a game of darts, which is a great example from our textbook. Imagine a circular target. If your dart hits exactly on the circle's bounding line, boom, you get the top score of 10 points. If it lands anywhere inside that circle, you get 5 points. But if it lands completely outside the circle, 0 points. The mathematical boundary rigidly dictates the rules of the entire game.
Section 5. Creating circular designs. Art with simple rules. All right, we've mastered the math, found the center point, and learned the rules.
Now, let's shift gears entirely and apply this knowledge creatively. Our sources point out that complex, interlocking circular patterns aren't just stuck in math books. They are actually the foundation for the beautiful designs you see all around you every single day. These precise geometric patterns are woven into gorgeous clothing materials, they decorate our vibrant festivals, and they adorn religious places all across the globe. And they all start with just the humble circle.
You can actually create your own mesmerizing art with a super straightforward process. Just draw a straight line on a piece of paper. Then, place a coin on that line and trace a circle. Now, simply slide the coin a short, consistent distance along the line and draw another circle. Repeat this process, maybe 20 times, letting the circles overlap as you go. You're literally using rigid geometric rules to create flowing, continuous art.
And check out what happens when you apply that exact same technique, but instead of a straight line, you guide your coin along a curved path. You get this stunning, complex decoration that looks almost like a 3D coiled spring. And it is generated entirely out of those simple geometry rules we just talked about today. It's absolutely amazing how repeating a simple mathematical shape over and over can yield such incredible beauty.
Well, I really hope this explainer leaves you looking at everyday objects just a little bit differently. We've gone from recognizing basic round shapes out in the world to physically proving where their exact center lies, and finally to using those rules for some really cool design. Knowing that complex beauty stems from such simple, elegant mathematical rules, what hidden mathematical patterns will you discover in your environment today? Keep your eyes open and keep exploring.